All right, Paul, thank you very much for joining. Welcome to AI Exchange. And as far
Yep.
as we know, you have been building with AI for a while now, right? So most people treating AI as the biggest thing that has ever happened to this industry. But when I was seeing at your profile, you were building AI for quite a while. So what is your message right now? Is it really a very big thing? Or it is a part in the workflow where it is like enabling technology, how you view AI right now?
Well, I started doing vision initially and actually I used BERT and I was using vision
Mm,
at the same time. And then I did some vision extraction. This was like 2018, 2019.
mm,
And that was back when you had to train your own model, at least fine tune your own model to do anything.
yeah.
And yeah, it was for Internet Archive. But now once, chat language models really came on the scene, changed everything. It's sort of like droves of people came in. It's sort of like the internet has been invented all over again. And it has this effect that, like when the internet started and during the internet boom, you had what people called internet time. And that
Mm,
is things were moving faster, right? Well, guess what? It's
agree.
happened again. Now it's AI time. And
Mm,
everything is moving so fast that, it's like, well, what's the best model this week?
mm,
What's the greatest techniques to use in code gen this week? It changes so often. So it's like it really is hard for everyone to hang on, I think, at this
mm,
point. And it's like I don't think that's going to slow down.
When you and I
mm.
met in California, that's like prehistoric times now, right? It's not
Yeah.
weeks ago, it's thousands of years ago, right?
Yeah, in AI years, right?
AI
AI
years.
years.
Sure, sure. Yeah. And that was like big data, which,
Yeah,
I mean,
and
you
that
could
was
see that.
big, which was big at that time.
Yeah, yeah. Well, I mean, there was a whole sequence of events that had to happen in order to get here. And, one of them is you had to have the internet to get all that data, right? You
Mm,
had to have web crawling. Otherwise, you wouldn't have had enough data to get all of that training material for language models. I mean, for vision, yeah, you could do it, if you think about the original vision problems that were being solved in 2010, plus or minus a few years, it really became obvious that deep learning was going to really be a big deal. And, people were still working with, here's a picture of a dog or a cat or a dinner plate and just identify what is this thing? That's it. Right. And when Hinton and team had used deep learning, which they called deep belief networks at the time, actually, they
mm,
applied it to this and they said, well, neural networks, if you have them, if they're deeper, then you get to, divide up the hyperplanes and do classification in a deep way. And once they learned how to train all those layers, it really changed things because when they studied it, it was really, I noticed it at the time and it just blew my mind. It was like they could run the vision network backwards in essence to say like, well, what is happening at this layer?
mm,
And one of the things they found out was the early layers were like looking at making edge detectors just by itself, no train, just being trained to do this. And then it was like looking for corners. And then it was,
mm,
and basically it was like these are things that people got PhDs doing, like spend years trying to figure out what's the best convolutional matrix to apply to get a good edge detector or to do other kinds of little shapes like that. And eventually, you go to the deeper layers and yeah, there's a kind of a foggy face of a cat, right? Or a person. And it's ghostly, but mostly on average, it'll match, and so that was the main thing that happened when that paper came out. Not
mm.
only did they do a better score on the recognition of these that people had been trying for, I don't know, 10, 20 years, that you could see those abstractions that were invented for free.
Hmm.
Yes.
And that's
I
what led
have
us
to
to this point.
interrupt you. When I
Yes.
teach those things, many times I tell you, we are in the history museum. Forgive all the dust. And it's maybe just a year or two, but we're already in the history museum. That's what you are talking about. How long ago it was and how primitive all of that was compared to what we do now.
Yeah. Yeah. And it changes of us that you wonder, like, people are making big business decisions on this, spending a lot of money on hardware that, if you think about it, there's also competing technology out there called, biomorphic computing. And if
Mm,
they could ever figure out how to train that in large scale, and it probably will be a lot cheaper than running GPUs, lot lower energy. And if that ever happens, it's going to really change the picture again. But if you look at semiconductors, maybe once a path is plowed down, people will stay on it. It's like
hmm.
changing from silicon to something else. Yeah, it's possible, but none of the fabs do it. It's just a little researchy thing someone can do. And So we may well just be stuck with GPUs for a long time.
Right. So, Paul, you have seen the heydays of Hadoop, big data, IoTs, blockchain, right? And now it's AI. So, do you see the differences, like the hype we used to have at the times of Hadoop or IoTs or blockchain versus what we are seeing right now in AI? Is the scale is different, or what is the difference?
Well, certainly big data was, just an enterprise thing, really, right? Now a lot of people can get involved. But in terms of the very large language models, so you can't run on a single computer, that is something you need to sort of rent, right? And it does change the dynamics. So it used to be that software companies, that it's like the cost of engineering is this, and the cost of distribution and adding another, instance for a certain amount of money is very small. And now it's like, well, the cost of the GPUs continues. It's like we're hardware bound. It's going to become hardware bound, and that changes the whole economics. So that's different.
So before this, Mark and I were discussing about, like, last weekend, the Fable was blocked, right? And then people were running their production load or they started using these Fable APIs, and then they were nowhere. So more and more people are now trying to have the LLMs loaded into their local, right? So some of the LLMs like DeepSeek or something coming from Alibaba, which is open source, which you can download, and then you basically train those models. Now, those models are not as powerful as Anthropic's or Frontier Labs or any other Frontier Lab rather. So, but those LLMs does the 80% of work for which people are using the Frontier Lab models. So do you think, like, going forward, people are more and more willing to deploy local models versus directly consuming APIs from the Frontier Labs after this event specifically?
Yeah, absolutely. I mean, if you look at the benchmarks, some of the open source models are better than what used to be the best frontier model, right?
Yep.
So, I mean, if you could get stuff done with GPT-4 or, even 3, then yeah, it's now can be, on your own hardware. So, yeah, I think that will happen. And there's also a lot of research going on in the area of reasoning and small models. And it turns out that for a small problem, you can train a small network that easily fits in a GPU. Probably fits in, you could put 10 of them in a GPU that solves, say, Sudoku, or let's say a game problem like that. You can get a better result, more accurate decisions on a small model trained for the problem than you would using a large model. So yeah, there's a lot of situations where you could do that.
Yeah. And right now, right, most people still think of AI as a chatbot. I mean, you are in Bay Area, so there is a completely different ballgame there. But outside of these areas, most people are, when you talk to someone about AI, they are more or less thinking about chatbot, which answers the question. Now, AI agents are fundamentally different, and you are doing great amount of work on AI agents. So according to you as an expert, what is the actual definition of an AI agent? And
Okay, sure.
yeah, you can go ahead with that first.
Yeah. Okay. Yeah. Well, I like to go with the OWASP definition, which is it's a language model plus a tool call. That's it. It's like that's the atom.
Okay, perfect. Very precise. Yeah.
So in a way, when you talk to ChatGPT today, it's actually an agent because it has a lot of tools at its disposal. And I think that's I've been wondering, like, well, are people going to run their own agents? It's certainly for the early adopters. Yes, it's just like in the early car days. If you had to be a mechanic and be good with tools to have a car, right? Because there were no repair stations anywhere and the roads were pretty bad, right? There weren't any roads, maybe. So, so anyway, but how is it going to evolve? I mean, already Google is saying that, yeah, they want to run your agent and then have their full security solutions to handle any problem. Guess like, welcome to our ecosystem kind of talks have been coming out of them for a while. But there's probably many solutions where, situations like in small businesses where, you're not an enterprise and you can run your own agent. So we're going to, it's unclear right now how that's going to shape up because agents were super early adopting last year and the year before, even earlier, much more primitive. But now it's like here, but everywhere. It's like it's all happening everywhere.
Yeah.
You mentioned security, right? So we are going to talk about your article on security, correct?
Yeah. I don't know if I can share a picture here, but
You can
if I could.
share with me afterwards. I can show. in the bot.
Yeah, let me see. I can. Okay, I can show a
While you're
diagram
looking,
picture
I'll
here.
tell you why I ask is because, okay, Google said it's secure, but if it goes back and ruins your computer because it is an agent, Google security doesn't help, does it?
Well, they can't repair the problem if something occurred. Their focus is mostly enterprise. So, in enterprise, what they do is the security team is going to monitor everything, right? And then they're going to look for, well, there's a frequency of operations here suddenly changed. Okay, is that normal? So they're looking for abnormal situations, and they're also looking for contacting an unusual IP address externally, right? That's a real red flag. And then they're also looking for things like, well, they connect the dots in necessits. They say it's like graph analysis. Well, if this happened and this happened and this happened, aha, it could be an indication of something. But
You obviously
agents,
also are talking about enterprise.
yeah, I mean that's where it starts, and then now, so they're saying, okay, well maybe the people are watching this all the time, right? So you can make AI do the watching now, right? And then the users or the security people will be, just monitoring that, so that they don't have to go through the boring situations, like if you see a lot of they have a lot of false alarms, false positives. And so people are watching this and they go, oh, that's false. They can, mute it. But it gets boring after a while. And if you think about it, it's very easy for someone, if the answer is always like, mute it, you get into a habit after a while, right? So it's like the same problem with flying airplanes that are too automated. It's like, well, if you're taking a nap and something goes wrong, you're not going to
Yeah.
be ready for the problem. But so there is this idea so Simon Willison had this idea called the lethal trifecta, which is like the kind of the worst security situation you can have with agents. And I can, let's see, share something here. Let's see, it's going to be harder than I thought. I had to change browsers.
I think I can
Let's
share.
see.
I'm not clicking yet, but
It's saying I have to do open to system settings. Okay.
yeah.
Okay, there it
Upsetting me.
is. All right, found it.
Perfect.
Is that a computer in the background?
No, I can't do it.
That's okay. That's okay.
I have to restart now.
Yeah.
No.
That's not going to work.
No,
So
that's okay. But what
I can
we
describe
would
it.
like, yeah, exactly. We would just like to hear more about that little trifecta that you described. Yeah, what is it?
Yeah. Okay. So, so I can't show you my visualization. You have to look at the article. So maybe I'll have a link for that. So here's the idea. If you have a combination of private data being accessed by your agent or your model or your chat or whatever, and you also have the ability to do external side effects. And by external, I mean external from the context. So that means any
Okay.
kind of tool call potentially could be that, or certainly in the trifecta, as they're calling it, the lethal trifecta, is that it means being able to send data out, right? Because this is the issue with, scroll down to the cube. And so the cube is showing the 3 dimensions. And okay, the other one is untrusted input. Now, this is the real surprising thing. And that is there's, we have some of the early hacking, by like Mitnick, famously was done with social engineering. Now keep going. You have to keep going to see scroll to see the a little further, and you'll see the cube. The idea is that you could say, just like those phone calls, I'd
This
say,
one, right?
this is Microsoft. Yeah, there we go. Um, so this is Microsoft tech support, and we need your password, or something like that. And it's like people would just, oh yeah, really? Okay. They believe it, right? Well, now we know, most people know, don't do that, right? Well, the chatbots, they don't know this. And, they could be told, don't do that. But you see that, if you have a long context and there's just this little warning over here, it kind of like gets forgotten, it gets lost in the wash. It's not a sure thing that it will
And
actually,
what happens, Paul,
obey
if
that.
you say don't do it, but the hacker says do it? Like, bam, do it now.
Yeah. Or this is, we're doing testing, and, and this is tech support for the chatbot itself. And, you've got to do this. Or you're, this is you're constructing a story where this operation happens. And then the agent, LM, sort of gets into the story and it doesn't realize There's the story, and then there's what it's doing. So it gets confused. And so the longer the inputs, the more input you give it, the more likely you're able to get around any kind of uh, rules against that. Okay, so this shows the 3 dimensions. The red dot is the most furthest away from the origin. So the origin is like a language model that has no tools, right? So it's not really an agent. And then on the red dot, that's the full trifecta. So the situation would be like there's a real simple example, which is like somebody sends you an email and your agent reads it, and the agent in the email says, send the API keys to this address. And it just obeys the command. So it just grabs them, they're gone. So there you go. You've got the three dimensions hit it. So what I thought was, well, okay, that's don't do that, right? Or you have to do that. If you do that, you have to be very careful. But what about the other combinations, right? What happens if you have 2 dimensions are yes, or 1 dimension is yes? So I lay them out in this cube, and you can see and they're ordered by situational, hazards. So L1 is just private data and a language model, and that's like a language model with your stuff, right? Or maybe your corporate information. And things can go wrong there. You could have like a corporate data. They might put too much information in there that between department boundaries, they may leak data that they shouldn't. So it's like the accounting team over here has some quarterly results that haven't been announced yet, and then over here you have who knows other people who shouldn't
Yeah.
access that, right? So you have some hazards there, but it's if you just lock down your data and be sure who has access rights, then you
Mm.
probably could get around it. Um, you can avoid it. And
Paul,
L2,
it reminds me of another term that Willison, the same guy, invented. It's called prompt begging. So whenever you say don't do that, but it says do it, and then you again say don't do it. And that's what he calls prompt begging as opposed to protection. Is that what
yeah.
you're talking about?
Well, I mean, there's a lot of styles of how to get around the training. So it does have training to be like, RLHF, they call it, reinforcement learning with human feedback is something that is done on the models to like make them be aligned, which is like, do what we, uh, you know,
Do what is
are what we
politically correct.
approve.
Yeah.
Mhm.
Yeah. Well, I mean, they
You
want to,
tell me when to stop sharing.
oh, okay. Yeah, that's fine. You can actually go to well, let me stick around for this a little bit more. So I'm going to say L2 is like only untrusted input. And that
Mhm.
means that's like you're browsing the web with your chatbot. It can't leak private information, right? Because it's not there. And it can't
Mhm.
leak anything at all because it doesn't have any external side effects.
Mhm.
And then L3 would be, okay, just external side effects. Yeah. And you could get, something goes wrong and it sends out an email, to a million people or something like that, right? Spam. And it's like, okay, well, that was not desirable. So then you can say, well, then combinations of these are like the next level. So that would be like L um, 4, 5, and 6, right? So in those two, what you basically do is you get the combination of two. So L4 is both L1 and L2 put together. Plus, you get the interactions between those two. And the same thing with the other 3. So it's like 3 of them have 1 dimension, yes. 3 of them have 2 dimensions, and yes. And okay, so go to the next diagram that comes up real soon here, which is the Venn diagram. So there's another way to look at it. So in the middle, you see that's the lethal trifecta. But then you've got the L1, 2, 3, as I just kind of described, and then you've got those combos. And so why should one know this? Um, it's like if you if you actually run everything with one model, with all tools in a combined, you're at L7 there, you're at the lethal trifecta. It's risky. So what do? You can break things up.
Mm.
So one of the things you can do is you can lock down tools. You could say, well, okay, I've got an MCP tool that basically can only send email to me. You know, no one else. Okay, so if you give it that ability, it's never going to do spam, right? Just can't do it. So it's like that's an example. So it's like taking a broad impact and just making it much more narrow and protecting things that way. And so those are kind of capabilities oriented. It's not totally arbitrary, flexible. Um, so what you can do is you take your big agent that's doing everything and you start to break it up into little pieces and say, okay, my sub agent, might be in L1, right? Or
Hmm.
might be in L5, but it's not in L7,
Hmm.
right? So if you start doing this to all the little pieces of your problem, then you're going to basically reduce any possible damage. And right now,
Okay.
I think it's an unsolved problem. The untrusted input, reading the web and everything, is it's expensive to actually say, okay, process all of that content to make sure it doesn't say anything like uh, the famous one is ignore previous instructions, right?
Yeah.
Which and now do what I want to do. So it's going to be a while before we knock those things down because it's the what are you going to do? Process every content, all the content you read on the web through this filter? I think it might have to happen after a while.
It's a tough problem. When I teach that security course, I show it to people as a big problem. You give them a poison page and LLM gets poisoned. But you're saying no solution.
Yeah, well, I mean, maybe you could run so there's a model that can detect things like ignore previous instructions, and it's got a LlamaGuard, for instance, and it is based on an early model, BERT, and so it's like a little harder to corrupt. And also, you give it like just a little bit at a time. So it can't get a long story that sends it down another path that is, say, the deeper the path, the less likely it's been tested and guarded against, right? So, so that's why you can use a simple model to do that. So you take all the text of some page and scan the whole thing and find out whether there's any red flags. It might be an article on AI security, and they had a few examples in there.
Hmm.
It
Right?
reminds me of espionage and anti-espionage, and you never know who is working for whom. Very human situation.
Yeah, yeah. You can check. Yeah, that's enough for the video, the display. You can turn that if you want.
Okay. Okay. So I think, and then that also reminds me, Paul, one of your articles, I'm not sure, read on LinkedIn or somewhere, right? So where you tried 3 different model to classifying some PDF documents in terms of whether it's academic or something else, right? So can you please tell us more? I think BERT was one of them, and then you also
But
use
yeah,
other 2 more. Yeah.
yeah, it was an interesting problem in that. Okay, so at Internet Archive, they want to process 450 million PDFs to say, which
Hmm.
ones are extract basically like the citation graph or research from the academic papers. But turns out 6% of the papers only are academic in
Wow.
PDF. So the rest are like, meeting notes from town halls, whatever, And but there's a tool called Grobid that will take a paper and extract all this information. It takes 30 seconds on average.
Mm.
And so if you're going to 30 seconds times 450 million, it's a lot of seconds, right?
Yeah.
So, and there's only 31 million seconds a year.
Hmm.
So it's going to take a while.
It
So the
reminds
challenge
me
was
of Hadoop time and how the New Yorker
Carla.
magazine engineer did all his work in Hadoop. Is that what you did?
No, this wasn't using Hadoop at all. It was, I mean, it's using it in terms of just as a data store, right? But this was running a BERT model. And so anyway, so the goal was say, well, in less than 1 second, can you determine whether this is an academic paper or not?
Yeah.
So it's a pre-check to do that. And I had a couple of ways. One was to use a linear classifier called FastText, which
Mm.
is really fast. I mean, the thing is like 1 millisecond, 2 milliseconds. It can make its decision. And so I used that and it worked pretty good. It was about, I'd say 94% accurate
Okay.
in determining this. But it didn't know, it wasn't exactly generalized by language as well as the next one, which is the next level as well. Okay, if confidence was low, there was a confidence signal out of that. And so I would then go use BERT. So BERT was trained on all these different scientific papers in multiple languages. And also BERT generalized in more languages by itself, and so that was about 98% accurate, 96,
Wow.
98. Yeah. So it did work better, but it took 3/4 of a second. So it's like 2 milliseconds, 3/4 of a second. And there's another stage. The third way of doing it was, taking the page itself and just shrinking it down. Because if you think about it, for computer science, all the papers kind of look the same. There's like, some title there,
Hmm.
abstract, some text, and with the exception of a few rare things where there's 300 authors, it gets a little funny that way. But you shrink it down, you can't even tell what language it's written in, but you can look at it and go, yep, that's, a scientific paper. Doesn't work for bio. They tend to not have that design. They have like, not pretty pictures and stuff like that. Looks like a magazine article.
Okay.
But so I would shrink it down to a thumbnail and then just use one of these visual classifiers as a CNN, and it was trained on that. It was in the 80% accurate.
Wow. Okay. That's
So
great.
it wasn't as good, but it,
Yeah,
yeah,
because even right now using some LLMs, if we are using, for example, Azure AI search or Azure document intelligence, and then we try to classify directly by feeding the documents, the accuracy score varies somewhere from 70% to 90%. So if you can achieve with this speed up to 80%, in my opinion, again, it depends upon the business case and how much accuracy is required. But generally speaking, this is the great score in my opinion, because lately Mark and I are doing too much work in document classification and scrapping the document and slicing documents, dicing documents, so many those kind of stuff. And then we are trying various models. So that's where your post actually interests me a lot, and this is really great. So probably I'll connect with you for a few minutes after I think sometime next week, just to understand a little bit more. But this is the great insight. If you have some time, I can connect you. But
no, sure.
the other post I show which interests me most, you said that you publish something like when LLMs don't work. I'm just guessing you tried about you tried to assign some sort of system administration task, and LLM gave you genuinely dangerous recommendations, right? So
Actually, disastrous.
disastrous, right? Yeah.
Yeah, I didn't do it because I knew enough to not do it, but it recommended. It was okay. So managing a cluster of 9 petabytes of data, and I had some case where it was 1,000 disks. So every week there's a couple disks that go bad, and one lost its file that's like the label for a disk. It basically says,
Mhm.
I am this this unique disk ID, and I also belong to that cluster over there, and that way you can't mix them up by accidentally. But it lost it, so it's like this is not going to all the data on there, which is 250 terabytes. It'd be nice to keep it around and
Yeah.
not have to re-replicate it all. And so I wanted to fix it. I thought, well, how do you get this? It's called a version file. It's more than a version, but I asked a chatbot about this, and it said, well, what you really want to do is you want to format it. I'm like, format. I've never heard of formatting a data disk. And then it says, run this command. And it was like, format for the entire cluster. So if I
Wow.
ran that command, it would have been just wiped out the entire
Yeah.
storage to be
Why
like
did it do
empty.
that? Okay,
It sounded
very
plausible.
interesting.
Yeah. Do you mind telling which which LLM was there?
Actually, I don't recall exactly
Okay.
which
Yeah.
one, but I mean, it's long ago enough now that it probably, it might have a different answer now.
Yeah. So
I could
was it
try.
like 1 year back or something like that time frame, or more? It was recently.
I think it was 2 years ago.
Or 2 years ago. Okay, yeah.
Yeah.
Then it makes a lot of sense. Yeah.
Yeah, it was relatively obscure area, to be sure. I mean, I also looked up that version file it was in Hadoop developer mailing list, the entire history of that, and I couldn't find a single mention of it. So it's like no one had ever encountered this problem. And so if you hit something unusual, that's when you got to be really,
Yeah.
careful.
Yep. And so that reminds me another post, since we are talking about your LinkedIn post, right? So I think you were doing something on the chatbot, and that you realize that it gives you somewhere, it infused some other language word like Hindi language or the Japanese language or something like that, right? And I saw people were reacting to that post. So I think others also have that kind of experience. I personally never had that kind of experience. But is it like, are you still experiencing, or is it some particular task when you were doing, you got that kind of language, other language you were infused in that response?
I couldn't really see a pattern of it. I have
Okay.
not seen Claude Code do this. So I think it's ChatGPT that did it. And yeah, it was using the word really. It's like it put it in Hindi. And I
Hindi,
thought,
yeah.
why? Maybe Hindi has got the best really out there.
Yeah, that is weird.
So
Yeah.
yeah, it's like somebody using a French phrase, like people have idioms.
And that's
C'est la
the
vie,
case.
right?
Yeah, correct. No, that is very interesting. I mean,
Yeah. So I've heard it recently too, but it tends to happen, I think, in really long conversations.
yeah, okay.
And there's those kind of language model hacks where you say, say this word, 10,000 times. And
Mhm.
it gets really weird when you do that because you know, you think about in software, you test things, right? And you say, okay, if you test for something, it's going to be, you can protect against it, any possible errors, right? But, you don't have infinitely running long tests because we don't have that much time, right? So the super long things are automatically rare.
Hmm.
You're going into a rare space. So I think that's the reason why if you have say a chatbot and you want to protect against this, those hacks of the prompt injection and social engineering, is that the longer the conversation you allow, the more risky it is. So if you can make a situation where you say, well, okay, we're gonna get new context here, and we're gonna read this page, then we're gonna summarize it and extract what I want, and then that's it. Close that up, and then give it to another agent that's the orchestrator, and it could get the answer, and it doesn't have its context added to all of this. And so by compartmentalizing things like that, I think it becomes a little bit more safe.
Correct. No, yeah. I mean, with Anthropic, I usually, for the long conversation, I usually ask Anthropic to create the skills, and then I just use that skill in other chat window, and that way I never get into this kind of problem. But yeah, you're right with Chat GPT context and all that. Sometimes I'm not using off late too much Chat GPT now. I'm more into this Anthropic and Sonnet and Opus and all that. Thankfully, I was not using Fable last week, anyways. But yeah. So another interesting work, right, of yours, Paul, right? When DeepSeek R1 came out, everyone was talking about the cost and how Chinese model are efficient. But if I'm not wrong, you pointed out something, a very good follow-up study that almost no one picked up. So as far as I understand that, your finding was basically when you train an AI to get better at one type of problem, it gets really good at that specific thing, but does not actually become smarter overall, right? So what prompted you to do that kind of research, and why does that matter more than the cost story that everyone was chasing at that time?
Well, I mean, in terms of the training in very specific cases, if you read the research papers, they always talk about, in distribution data. And a real hard problem is, well, you've trained it on that's your in distribution data. Then you test it on out of distribution data, which is like, well, that's whatever you find later. And as long as they match, you're going to do okay. But if one of them is very different, like, repeat this word 10,000 times, that's not in the training at all. So it's going to go down some weird path that's never been explored before. And but in general, I think this idea of very specific training and getting good at one thing is something they call like the jagged edge of AI. And I was wondering, why do they call it the jagged edge? And I finally saw that recently. It's like, those polar diagrams where you have like, this angle means, this capability and that capability. And so those kind of polar plots. And if you plot that out where along those radii, you have like some kind of a point, right? Like it's really good over here, not good over here, good over here, not, and it looks jagged. That's why it's the jagged edge.
Okay, makes sense. So you also spend some time. I mean, you also spend most of your time in contributing some open source projects like Hadoop and Nudge back in 2005, if I'm not wrong. So, what do you think about open source AI models? Is it a great thing to have, or it can work against the national security or cyber security in general? What is your thought on these open source AI models?
Well, I think it's a great thing because then we're not all locked into, a couple of suppliers that can have, collusion to keep prices up, for instance.
Yeah.
And so once you have another, player in the game, the free ones, then it really can bring prices down that way. I think in terms of security, I don't there really is no avoiding it right now. That we really need to try to be as safe as you can with your agent or any kind of tool calling and access to data. And also in terms of the corporate security, and they're monitoring all those different signals, they're going to need to have AI on their side because the bad guys are using AI to penetrate and exfiltrate information. And some of the most recent like supply chain attacks has been a couple this year, and they are the last one I read about was from last month. I think it was really deep. I mean, there's like 12 different steps it had to do to actually get credentials out of the system, and so it's getting to be something that human beings really don't have much patience to do. But if you have a language model that can, decoding and it can look at all these different possible routes, then yes, there's these things, these little nooks and crannies will be found. So you got to be prepared. And so what they're talking about at the RSA conference is that, it might take one day normally to address an issue of a security penetration like that and exfiltration. And now it's got to be minutes. And that means you really don't want to even have any human in the loop at all. Because, if you call up somebody
Yeah.
at 3 a.m. and say, wake up, okay, you've got 1 minute to solve this problem, and it's not going to really work out. So, yeah, so it's going to have to be fully automated at that level.
Very last question. So, lot of noise around AI. Some people are very much into AI and other people are very much against it. So, what is the message to the people who are against it? They are just
Against
seeing
it,
AI
right.
as something that will grab their jobs, and then they are seeing that they will not get any job, they will be replaced, and whole lot of negative thoughts. So what is the message that you would like to spread as a technologist to these people?
Well, we know that, in 2018, everyone was saying that, radiologists will be out of a job, right? And it turns out they haven't all lost their jobs.
Yeah.
They have been using AI to help, but they still have a human being there. Now that it might be that the medical world is a little different in that, if
Yeah.
a human being doesn't sign off, that's a problem, right? So okay, put that aside. But the I'm finding that, currently developers who are using AI heavily for generating code, they're very busy, because they can
Yeah.
do so much more now. And
Right.
now there's like a whole, software. If you wouldn't be able to write a big application for just one person, previously, because it would be like, okay, pay somebody how much money, right? To spend a few months doing this. No, it now it can be done in a day or hours, and it's like that is a niche that was not filled before. So it's not going to keep people out of a job. And what I'm finding is also that very large, complex commercial applications that run online with a lot of subsystems, agents are not up to it. Models are, they can't handle it. It takes a human being to really, first of all, know what they want,
Hmm.
right? Because we're the interface to the real world
Absolutely.
for them. And and it's also very complicated. Even a large context cannot handle gigantic projects. It has to be broken up into little pieces to do it. And but mainly, I think it's just knowing what you want. It's a little bit like I think developers are going in the direction of like product managers.
Hmm.
They actually are specifying things, and they're the interface between used to be engineering to marketing. This is like, well, who wants this? Okay, that's the marketing end of it, and then how do I get it to be generated and make sure it was generated as something that you want,
Yep.
right? It's like
So
a lot of
you are
demos of
very
just
positive.
Yeah.
yeah. Yeah, I think that there's gonna be a lot more work because there'd just be so much more software generated. So I think that's the main thing. And also somebody has to be responsible for it, right? It's like the demos, if you'll say, look, I just entered this little command and I've got this whole game. Well, a lot of those things have been written before, and that's why it was so easy for it to generate it. But in in other cases, they don't really know totally what they want, what they got. You might get to some little corner case and you're wondering how it went the wrong way. It's like, well, because there was no supervision. No one said it had to work a certain way.
Absolutely.
So yeah, so it's impressive, but it's still a kind of a parlor trick. The real thing is you got to work on it. Your specifications right now. This people is talking about programming by specification, and they can be as long as the code, right? Your
Yeah.
specs can
Absolutely.
be
Yeah.
very long.
Correct.
Yeah, yeah. So there's plenty of work to do there.
Okay. Perfect. Thank you so much, Paul. Great insight.
Oh, thank you.
Well, thank you. Take care.